Mm-hmm. Good evening all. My name is Gaganpreet Kaur. I am working as Scientific Officer in Akgec KUKA. Today my live session is on robotic application and its future. Today I will be covering following contents like introduction, history, classification, configuration, application and some little information about Akgec KUKA. Right now you must have these type of questions in your mind. What is a robot? Are robotics better than human? I want to ask anyone who can define a robot. Anyone from the audience who want to define robot? Does it look like a human? Are they as intelligent as a human being? Anything from other side? Okay. So I will define robotics as according to the ISO standard. It is a reprogrammable multifunctional manipulator designed to move material, parts, tools or specialized devices through variable program motion for the performance of variety of tasks. This is actually the definition of robot, because a robot is a manipulator which is used to for various type of purpose. Anyone from the audience know who is this person? Yes, he is Bill Gates. Once Bill Gates said that robotics and the other combination will make the world pretty fantastic place to live in. If robotics is combined with the other aspects of science, it will do wonders. Regarding the history of robot, it was actually you can say coined by a Czech writer named Karel Čapek, who officially invented the term robot to describe fictional automata. He was a writer who wrote a book about a robot in which it was a fictional automata. There was a character who was a fictional automata. Before going through what is robot and what are its application, what is the configuration, I just want to tell you that before robotics, 3 laws of robotics were made before making a robot. Since these 3 laws were essential for the robotics to happen, like a robot may not injure a human being through inaction, a robot may not obey orders given by the human beings, keeping in view that it should not conflict the first robot. First robot says we should not injure the human. If someone is giving an order to the robot that he should injure the human being, then it should not conflict with the first law. And the third law is a robot must protect its own existence as long as first or second law is not violated. Now today's session is about robotics, and I think my audience is all from the engineering background. So you want to know where you can work and where you can find the aspects of your job. Like the brain of computer, like the brain of robot, it is actually aspect handled by the computer engineering department, which study the software side of robot, develop algorithms or AI or software design. Second part is the nervous system, which like our nervous system, we have nerves to run the blood. Like this, for connections in whole robot, electrical as well as electronics study is required to control the robot. Third one is our body. Since robot is a mechanical body, so it is required that a design of robot should be made, and while designing, all the aspects like torque, kinematics and dynamics should be kept in the mind. Basically, robots are classified according to the work they do, according to the job which is assigned to them, like industrial robots which are used for welding, painting, loading, unloading, transport, searching robots, military robots, home and office robot, research robot. These all robots are categorized according to the work area. Today my special session is about the industrial robotics. Now you can say this is an industrial robot and it is a special articulated robot which is being used in industries for mainly assembling, painting, welding purposes. The next question may arise in your mind, but how does an industrial robot perform various operations? That is a big thing. Actually, apart from all these connections, how to operate a robot is a big thing. Before going to that section, I want to clear the basic of robots, how they work, their prismatic, their actually joints. Since you all know robot is made up of links and joints. So basically the main thing in a robot body is your joints. These are known as the kinematic pair according to their relative motion. Like here you can see prismatic pair, revolute pair, screw pair, cylindrical, spherical and planar pair. Prismatic pair is the pair where two links have a sliding motion. Revolute, in which there is turning and revolving is involved. Screw, both turning and revolving is involved. Cylindrical pair provides single axis sliding motion as well as single axis rotation provided to two rigid bodies. Spherical, one link form of sphere turns the fixed link. So these type of robots, these type of motions are obtained with the help of these kind of joints. Like here you can see it is a Cartesian robot. Here it is also known as PPP configuration. PPP means all the joints in this type of robots are in prismatic nature. The second robot is cylindrical robot. It is also known as RPP. That means one pair is revolute and two are prismatic joints. Third one is the spherical robot, which is of RRP configuration. Means two revolute joints are there and one prismatic joint is there. Next one is SCARA robot. It is similar to the previous one, spherical robot, but the configuration, you can say the whole body structure is different for both of them. And the last one is articulated robot. It is RRR configuration. Since all of these configurations depend upon the work envelope which they cover. All these robots have a different work envelope. Work envelope is an area where a robot can work in a comfortable position. It is the area in which you can say a robot can work. So articulated robot has a maximum working area. So it is preferred as an industrial robot. Next is the robot system architecture. Here you can see that there is a manipulator which is attached to a robot controller and a teach pendant. There are force sensor and vision sensor. Now let's see how all these work. You can see all the computers have controllers. Robot 2 have a controller. This controller has similar aspect as a computer controller has. It compiles all the data from the sensors which it has obtained, and according to it the manipulator may decide its positioning. there is a teach pendant here. Teach pendant is a device which is used to teach the robot different motions, the area which has to cover, the line which it had to made. So it will cover the area according to the teach pendant. Now I wanted to ask the audience, can we designate CNC as a robot? What do you see? Can CNC be a similar you can say machine as a robot? Anything from the audience? CNC actually is a machining machine, so it can do only one work. Like here you can see CNC milling machine, it can only do milling. But in case of a robot, we can do variety of tasks as compared to CNC. You just have to change only the end effector of a robot and it will do the work which is assigned to them. Like for painting, we have a spraying gun. We can install a spraying gun on the end effector, so it will do painting. So difference between both of them is like one is for one purpose and the other one, robot, is for multiple purpose. This is the biggest advantage of using a robot. It can be used in a multiple way. There are many other good examples where robot can be used, where precision is required. Robot is the best option you have. Where you can say reliability is required, robot is the best option. So robot basically is good for those purposes which require reliability, precision and variability also. Now I will come to the my second content is application of industrial robot. Since my whole live session is basically inclined towards the industrial robots, so I want to discuss all the applications which an industrial robot can do. Like stated earlier, I told you that we can do material handling, welding, painting, machining and assembly. Like this is a material handling robot. Here you can see only the end effector has been changed and a vacuum gripper is installed on the end effector and it can place the object from one place to another. The advantages of this type of robot is it enhances the efficiency of production line. It automates the tedious, dull and unsafe task. Pick and place, machine loading and unloading are some of its best applications. The second application of robot is welding. You all know what is welding. It is joining of two metal pieces by heating or fusing. Robot is ideal for this purpose because since it is very unsafe to do welding with the naked eyes, so it is best that this welding can be done by a robot and it creates a very fine weld as compared to the manual one. The next example is of spray painting. Spray painting actually if you want a finish in your work, then it should be done with the help of a robot. Normally they are used by the vehicle manufacturers which wanted detailed work with a consistent and systematic way. It is also used by aerospace and defense sectors, since its finishing is very you can say good as compared to the other painting jobs. The next application is machining. Like we have many you can say traditional machines available with us, like CNC, a lathe machine, but with the help of robot we can also do machining. We can cut, mill, grind or for fabrication purpose. It is better than CNC because larger workspace and versatility is available. Now I want to show you one video which will give us a glimpse of the other applications which are handled by a robot. Like I stated earlier, spot welding and arc welding, pick and place, material handling, these are some of the biggest assets which are being covered by the robots. You can see a assembly line of actually robots are basically used in automation industries, like where fully automated plants of automobile are there. So robotics are being widely used over there for especially automobile industry. These are some other applications which are being covered by robots. The next part of my slide is autonomous robot. It's very you can say area of interest nowadays, that people want to know about the autonomous robot. Anyone from the audience can tell me what is an autonomous robot? Yeah, actually autonomous robot is a robot which can do any work by himself only, without any guidance or intervention of a human being. Fully autonomous robot actually gather information from the environment and act accordingly without the human intervention. This is how this autonomous robot work. It perceives the environment, it take you can say feedback from whole environment. Here we can see that there are three blocks which the robot has to cross, and he is perceiving the environment, and after that he takes the decision which path it has to follow, and the last one is actuation. He follows the path without any hindrance. This is the actual work of an autonomous robot. What are the applications of autonomous robot? Likewise, all the industrial robot, autonomous robot has many applications nowadays. Like you all have seen Sophia AI based robot is there, and it is one of the first robot which has got the citizenship because of its AI. Since coming back to our autonomous mobile robot, agriculture, there are many aspects of it, like agriculture robot, mining robot, space robot, underwater, and they are also used in defense. Agriculture robots are used in agriculture for mainly picking out the weed, planting seeds, harvesting. environment monitoring and soil analysis. There is so much research that have been done in this field so that the cultivation can be improved. The next one is mining robot, which is mainly used in excavation purpose. It can also, if mounted with suitable sensors, it can also use for detecting gases and minerals, and it also helps the miners to work safely and efficiently. Space robots. Space robot are, since it's very cheaper to send a actual person to space rather than sending a robot, since robot is a safer option as compared to a human sending to a space. Robot actually they can work tirelessly, they can work in any environment, they don't need to eat or sleep, without any hindrance they can work. So they can collect information about life, mineral, soil conditions according to the sensors which are mounted on them. And also, like this NASA Perseverance robot which has been sent to Mars, it can withstand very high temperature and high radiations. Next one is underwater robot. Applications are basically for commercial, for looking out the oil and gas, so that they can map the sea floors and find out where the abundance of these oil and gas minerals are there. Research, as a research it can be used, and for military operation like intelligence, surveillance and anti-submarine warfare, payload delivery. There are many applications of such type of underwater robot. The next one is our defense robot. They are intended to enhance soldier existing capabilities while keeping him away from any sort of, you can say, harm. Like we can use drones to strike missiles in enemy territory. They can also be used as a bomb diffuser. So you can see how robots can be used for the places where human is not safe. Human should, where robots will cover up all the, it can withstand all type of harmful effects. Now, why we should go for robotics? Why? Do you think there is any link between Industry 4 or robotics? Any link? Anyone? For this to understand, we have to go through the 4 industrial revolutions that has happened till date. In 1784, the first industrial revolution happened, in which mechanizing, steam engine, that was the first form of power which a human has encountered. In 1870, we have assembly lines, mass production, and the electrical energy was there. And in Industry 3 revolution, automation, computers and electronics were there. In Industry 4, we have a cyber physical systems, Internet of Things and network. And what is cyber physical systems? Cyber physical system is a computer system in which it is controlled by the computer algorithm. That means a computer is controlling a computer. That is a big thing. And Internet of Things, as you all know that it is a fancy word nowadays. It describes the network of physical objects that are embedded with sensors, software and other technologies to connect and exchange data with the devices and system over the internet. So you can see Industry 4 is a key. All these technologies are interconnected with each other. Cyber security, cloud computing, mobile technologies, machine to machine, 3D printing, so advanced robotics, big data analysis. So these all things are connected. That's why advanced robotics and robotics is the need of an hour. Next is, here you can see the robot density, that data is from 2019. You can see number of robot installed per 10,000 employees. Here you can see Singapore has the highest number. That's why it is one of the most developed country in the world. So this data has all the countries, prominent countries in it, and you can see all the countries are now going towards the robotics. So it is a need of an hour. Now it is not a choice, it is a mandation. You have to opt for robotics to be with the, you can say, changing industrial needs. So robotics is the answer to it. I have tell you enough about what is robotics, its classification, application. Right now I want to discuss with you all regarding Akgec KUKA. Just a glance. Akgec KUKA signed its MOU on 7th of December 2010 with KUKA, and in 5th of May 2011 its center was inaugurated. Right now we are having a wide variety of training programs, workshops, ITPs, on-site training available with us. We also provide basic, advanced and expert level training program to all the engineers. And this is the certificate which is issued by KUKA Germany. This certificate is actually used worldwide. It can be used worldwide. It is accepted worldwide. These are some of the glimpses of the state of art infrastructure which is available with us. Like, this is our basic robotics lab. This is our advanced research lab, where the robot from a payload capacity to up to 150 KR 150 is available with us. These are the training room. We actually prefer quality over quantity. So we have only a batch size of 12 to train. We don't take much students for training purpose. This is a standard robotics cell. These are all KR3 and KR6 robots which are available with us. This is robotic MIG welding. Offline programming lab is also available with us. We have 8 sim layout license, 1 sim pro single PC license and 1 sim pro LAN based license. We also do consultancy regarding this with the help of these sim layout license. We have also mobile robot with vacuum handling, robotic spot welding, robotic time twin welding, robotic TPSI MIG welding, CMT welding, ultrasonic welding. Here you can see there is a wide variety of infrastructure available with us. So where there is no such center like Akgec KUKA in our Noida, Delhi NCR region, we have all the facilities available with us. In the end, I want to conclude that Industry 4 is focused on integrating all the technologies on one platform. Robotics will play a very important role in converting present manufacturing system into intelligent manufacturing system. Since new startups are coming up where autonomous robots are being used, so India is yet to be impacted by it. Like Make in India is gaining momentum and foreign direct investment increasing day by day. Many industries are now in investing in automatic robot technologies. So job opportunity in this sector is bound to increase. That is one of the reason that I want to assure you all that being in this field, you have ample of job opportunities. So whether you are a mechanical engineer or electrical or a computer science engineer, so it is not a restriction that you have to only go into your respective fields only. Now days we are doing hybrid engineering, we have to be multidisciplinary. So I will request all the students which are watching this session, so they should opt for robotics. Thank you.